Okay, so in the previous video we made the 3 LED light chaser, but the code was not too pleasant. So I'll just remind you, so we run it so the lights are actually going to flash from pins 8, 9 and 10 and keep cycling around. When we look at the code, it was fairly full. One of the key principles in programming and also data management is that we like to have, we don't want to repeat data. Alright, so we've got our setup. We set the pins 8, 9 and 10 to output so we can hook up LEDs and make sure they turn on, etc. We then told 8 to go high and the other 2 to go low and wait 0.2 of a second. And then after that we changed turn off pin 8 and make pin 9 high. Can you see how this is just repeating the same block? So that is not good, and sometimes it can actually take up much more memory on your Arduino and you've only got a certain amount there. So we don't want to repeat and we don't want to take up more memory than we need to. Alright, so we're going to cover two new topics. We've got variables and functions. Now, I'm just bringing in Excel here. When you want to do a calculation in Excel, you go 3 plus 2 times 4. Okay. Every time you want to change it, you'd have to go back in and go, alright, I want that to be a 5. You'd have to keep on changing it and the actual coding and the function. So the best practice is 2, 3 and 4, and this is going to equal whatever's in A2 plus whatever's in A3 times whatever's in A4. So now if I need to change a number, it will automatically recalculate. So I don't have to keep on fiddling with the internal structure there. So we're going to do the same thing in Arduino using the Tinkercad environment. Alright. Now, A2, if we wanted to, we could actually rename that. So I'm going to call this one Bob. Alright. So I've just renamed A2 to be equal to Bob. A3 can be Jane. And A4 can be Fred. Okay. If I go back and alter my functions, I can say Bob plus Jane times Fred, wasn't it? Yep. Now, what did I do wrong there? I didn't hit enter. So we'll call this one Jane. Now it's called Jane and the function works. So what we've done here is just simply, these are variables. So they're little boxes that we can actually store numbers. Okay. We're going to do the same thing in Arduino. Alright, so this is going to be constantly repeating itself. So I'm going to delete this for now. I'm not going to delete this because I'm going to do some Slack stuff and I don't want to do any typing. Alright, I'm going to make my own function. Now it's not going to report any values back, so I just use void. If I need to pass a value back like I was doing in Excel, then I'd actually have to say what type of variable, so it'd be int, etc. for integer. Alright, so we're going to call a function that keeps on using all of this information here. So I'm going to call this function Bob. Okay. Now, Bob is going to have some values. The values are whatever the state on pin 8 or LED 1, and whatever is the state on LED 9, and whatever's the state on LED on pin 10. So I'm going to call these ones booleans. Now a boolean variable is either true or false, high or low, or 1 and 0. We like to specify those low values because it actually takes up less computer memory. So I'm going to call this light 1, and I'm going to put an S there, light 1 state. And I'm going to put in another variable here. This is going to be light 2 state. Oops. Light 2 state. And light 3 state. And also I'm going to make an integer that's going to hold the delay. Alright. So I'm going to call this one, we'll call it pause. Alright. Now it is a function, so you need some curly brackets there. Alright, so I'm going to cut that, paste it up there, because remember it's all about being slack. Alright, so light state 1, so light 1 state, and then this is going to be light 2 state, and this one is going to be light 3 state, and the time is going to be pause. Alrighty, and don't forget the curly bracket to finish off the function. Alrighty, so I'm now going to call in the main loop of the program Bob. Okay, so Bob, I want it to be the first light on and the other two off, and I want to pause for 200 milliseconds. Call Bob again. Light 1 is off, light 2 is on, light 3 is off, and we'll pause 200 milliseconds. So these values that I'm typing into here will actually go into here and then go into their writing to the pins. So if I put a 1 into the second place, that's going to be light 2 here, and then that value will be passed into there. And one more, because we've got 3 LEDs. Turn the first 2 off, put the last one on, and pause for the same time. Alrighty. Make sure you got all your semicolons in and all the brackets there. So if I actually start the simulation now, alright, so you can see how it's actually spat the dummy there. What I've forgotten to do, good old programming, is actually tell the computer that light 3 state is a Boolean variable. Alright, let's see if it's happy now. It's happy now. Okay. So if we go back to the light chaser here, you can see it's going along. Now the good thing about this, I'll just zoom out a bit and, oops, Control Z, gotta love Control Z. Alright, if I want that one to go on for 200 milliseconds, that one on to 400 milliseconds, and this one on to 600 milliseconds. That is a lot easier than having to go through each one of these copied blocks of code. We had 3 of them, and manually adjusting them. We can just do it into here, and it passes all the values back into our function called Bob. So if I start the simulation, alright, so the first one comes on quickly, second one's twice the length, and the last one is slow because we've actually done it there. And I can sort of exaggerate it a bit more. So we'll make that for 1 second, and we'll make that for 2 seconds. Start the simulation. So very quickly, 1 second, 2 seconds. All right. Just remember, when you're actually using this online simulator, there is your clock. Okay. So depending on the power of your computer and connection to the servers, etc., time that passes in the real world is going to be different from the simulator time. Now, I've got a fairly gutsy computer, so more or less the simulation time will match reality time. Okay, so this is how you use functions to actually stop repeating code, to actually save memory space on your Arduino. All right, thank you.